All right, it says consider a series RC circuit. They give you the resistance of the resistor, 8 mega ohms, and the capacitance is 5 microfarads. Voltage of the battery, 26 volts. They want us to find the time constant of the circuit. And the time constant has a formula, and we use the Greek letter tau for time constant. And the way we find it is by multiplying the resistance of the resistor times the capacitance of the capacitor. It turns out to be a useful quantity when it comes to RC circuits. So we can do that easily for these guys. We'll do 8 mega ohms times 5 microfarads. All right, it's 40. Now the units of this will actually be seconds. And the meaning of it is that charge will build to 63% of its final value after 40 seconds of the switch being closed. So let me just draw a little graph of the charge on the capacitor. Okay, so we'll call that Q. Now this capacitor is initially uncharged. Just assume it's uncharged unless they say otherwise. And it's going to build up to a maximum value over time. Okay. Now that maximum value is called Q max. But the instantaneous charge is just called Q. Or sometimes Q with parentheses T, which means Q is a function of time. Okay. Now, once it gets up to this special value here, which is 63% of the final Q max, the time that takes is called tau, the time constant. And for this particular problem, it's 40 seconds. Okay. So that's what I would put in for A here, 40 seconds is the time constant. Now we can find the maximum charge on the capacitor after the switch has been closed. So for that, we want to ignore the resistor. Treat it as if so let's say, when t goes to infinity, we're going to have just our battery and our capacitor. And nothing else matters at that time. So if we have 26 volts on our battery, we have to have 26 volts on our capacitor at that time. So you just want to do the formula Q max equals the capacitance times the voltage across the capacitor. So 5 microfarads, 26 volts. All right, it looks like 0.00013 coulombs, which is the same as 130 microcoulombs. So that's what we would put here. Now, just for fun, let's figure out how much charge is on the capacitor after one time constant has passed. So to do that, after one time constant, this is after 40 seconds. The Q on the capacitor can be easily found by doing 63% of Q max, which is 0.63 times 130, 81.9. So we would write that like this in function notation. The instantaneous charge after 40 seconds is 81.9 microcoulombs. Now, I didn't actually ask for that number, but just, just to show an example of what the time constant means, I just did that one briefly. Now we'll answer the question that they actually asked, which was find the instantaneous charge 10 seconds after the switch is closed. We actually have a useful formula for instantaneous charge where we can plug in any time and get the charge on that capacitor. It goes like this. The charge as a function of time will be Q max times 1 minus e to the negative k times t. This is just a general formula for when something exponentially approaches a limit, and that's what's happening with the charge up here. So all we have to do is figure out our Q max and plug that in, and we also have to figure out this constant k, which tells us about the growth rate of the function. So luckily, k can be expressed in terms of the time constant, believe it or not. So if I rewrite the formula, what it ends up being is the k is 1 over the time constant. Okay, so k is 1 over tau. So Q after, and I'll do the charge after 40 seconds just as a test to make sure it works. Okay, the time constant was 40 seconds, and I also wanted to find the charge after 40 seconds, so both t and tau are 40 seconds. Now I plug that into my calculator. It comes out to, not surprisingly, 82, I'm getting 82.2 microcoulombs. The only difference is due to rounding. 63% is actually just a rounded number for what the charge builds up to after one time constant. All right, last thing I would do now is to answer their actual question. I want to plug in 10 seconds. Okay, so the little t is how much time has elapsed. Tau is our time constant of 40 seconds, r times c. I'm getting 28.8 microcoulombs.